Hey there, good afternoon or good morning, algebra students. We are talking now with a new unit, and I just wanted to review a couple skills right quick. So first skill I wanted to go over was domains. Okay, so if you guys recall, domains talk about where does our function go left and right, or specifically a better way of saying it is, what are all the possible x values that could go into our function, as in what are all of the possible x values that our function has. So on this graph, right, we're basically looking at, well, right here, is there an x value that corresponds to a point on the graph? No, there's not. Okay, so what about over here? Yes, because so this x value, there's a point right up there. And this x value right there, the point is up here. And this x value, the point is down there. And so on and so forth. We get to here, there's another point. We get past there, there's no points on the function anymore. The function does not exist over there anymore. Okay, so in essence, what we're saying is our function basically goes from here to there, from a left-right standpoint, where this is the leftmost value, okay? And maybe this is 1, 2, 3, so maybe we'll call that -4 is the leftmost value. And it goes all the way over there, where maybe we'll count that as 1, 2, 3, 4, 5, 6, 7, 8. Okay, and it looks like I'm just a little bit off, but we'll say that that's 8. Okay. And so previously, what we've talked about was our domain. And we could write it several ways. We could write it in inequality notation from -4 to 8, where we're just caring about where it goes left to right, or also in interval notation, like this. So either way works, okay, depending on how the question is posed. All right? But we don't actually care about bottom and top if we're just talking about domain. So make that clear. When we're talking about domain, all we care about is left to right, okay? So this is incredibly important for today's new material because we're going to add in new function characteristics on our graphs. Specific characteristics would be, when is it increasing or decreasing? And the way we're going to answer that is specifically by saying, over which domain is a function increasing versus decreasing? Okay, so let's say we had a function and it starts out here. So we'll say there's a point there. It starts out there and it's going up. And then it gets to a spot where it starts coming down. And then it gets to a location where it starts coming up again. And then it keeps going up forever and ever and ever. Okay? Basically, this top of a mountain and bottom of a valley, those are points that are really essential when looking at increasing and decreasing regions. Because when we get to the top of a mountain, now all of a sudden we're no longer climbing up, we're going down. So this goes from being an increasing region to a decreasing region, because now it's going down. So we always read graphs from left to right. So we're saying we start there and we go up and then we go down. And then when we get to the bottom of a valley, there's nowhere for us to go except now up again. And so this is increasing now forever and ever and ever. So we're going to write these answers, just for time's sake, I'm going to write these answers in interval notation today, but it is essential that you understand we need to know those x values. Because when we're labeling our increasing and decreasing regions, we're not talking about what height does it go to, we don't care, okay? We're not talking about that whatsoever. All we're talking about is, what is the x value where it changes to be a new region? So this region would be an increasing region, we hit an x value, new decreasing region, hit another x value, increasing region forever and ever. So we need to actually have these points labeled. There's x is -1, -2, -3, we'll call that -4. So we've got -1 and -4 as our x value. So we actually need to know what those x values are. And again, we don't care about the height, we're just looking at this from a standpoint of, here's a region, here's another region, etc. Okay? And we actually need to know this scenario as well. So negative 5, 6, 7, and 8. So we'll say that this is at negative 8. I don't know if you can see that negative 8. That's pretty ugly. So I will redo that. Negative 8. There we go. Okay? Because it doesn't actually go forever over here. It started at this negative 8. So we're going to first label that first interval was an increasing interval. And it started from negative 8 and it went to negative 4. And we're not saying what height did it start at and what height does it end at. We're saying what left side does it start at, negative 8, and where does it end on the right, at negative 4. Okay? For our increasing and decreasing regions, we're always using parentheses because at these top of mountains, we're not going up anymore, so we can't include that as an increasing value. We're also not going down yet at the top of the mountain, okay? Just like we're not going up or down. That point, we're kind of paused at for a split second. So we don't include this point, this point, this point, or infinity ever in our increasing, decreasing sets, okay? So it's increasing from negative 8 to negative 4, and when we say from, we once again don't mean that it's increasing from that height to height. We're saying from left to right, okay? But we have to have a union symbol because guess what? There's another increasing region, right? The other increasing region is over here. So I'm going to skip this region for now because I'm just looking at my other increasing region. It increases from negative 1 all the way over to infinity. And I don't mean up infinity, I mean over here, infinity, because we're talking about domains, okay? So this would be our increasing region. The nice thing about this being a YouTube video, you can pause this and press rewind, rewatch it, etc. anytime you guys need to, okay? And our decreasing region, or our decreasing domain, that's a better way of saying it, because now we're really getting into the mindset of this being a domain. Our decreasing domain goes from negative 4 to negative 1, and again, we're just looking at those x values, okay? Again, you can pause this at your leisure, so I'm just posting that up there. Boom. Okay, let me highlight some things. Oop, I'll leave that there. Okay, why is this essential? Once again, so what do? We look at basically where's the top of a mountain, where's the bottom of a valley, where's a beginning point or an infinity symbol, etc. All of that good stuff. Okay, this problem could have been even more different if, let's say, this was an arrow over here. Okay, well, if this was an arrow forever, let me make this clear. This does not mean it's, so we don't read this as it goes down to the left, so it's decreasing now. We say we started all the way at the bottom of the earth, or whatever, negative and infinitely small, and negative left, and down and left, etc. Okay? We basically say we're starting there, we just started by going up. This is really, we're reading this as we go to the right. It still goes up. This is still an increasing region because it didn't like turn. Okay? That whole region is increasing because we're basically saying as we go that way, that slope would have always been positive. Another way of looking at this is increasing regions have positive slopes, decreasing regions have negative slopes, etc. Okay? If you were to look at like down versus up. Okay? The only way that would have changed this problem, this wouldn't have changed my decreasing region whatsoever. It just would have changed my increasing domain to now be from negative infinity, and again, that's from the left, not down. Negative infinity to, what do we say, negative 4, unioned with negative 1 to infinity. Because here would be the increasing intervals from here to here, and then from here to here, etc. Okay? So hopefully that has helped. And I am going to give us one more example of an increasing, decreasing problem. So let's just say we have here, okay, 1, 2, 3. Okay, so clearly negative 3 is the key component, or the key x value for this problem. right? Again, here's negative infinity on the left, here's positive infinity on the right, and all we need to do is decide which side is increasing, which side is decreasing. Well, this is going down, so that's decreasing, it's got a negative slope. This is going up, that's increasing, right? This goes down to the right, this goes up to the right. We always ask ourselves as we go to the right, okay? So our decreasing region starts over here at negative infinity, and it goes to -3. Our increasing region starts right here at -3, and it goes to infinity. Okay? So there we go. Hopefully this slide has helped. One other thing I wanted to add on here, since we are going to talk also about function characteristics, are x and y intercepts. So from a graph, our x and y intercepts, okay? These are our x-intercepts. They are where we cross the x-axis. We only ever write our x-intercepts as coordinates. So this would be -2, 0, and 1, 2, 3, 4, 5, 6, -6, 0. Okay? Another thing that, so this is really essential and important moving forward. One other thing that we call x-intercepts, another word for that is we call it a zero, because it hits the height of 0. Okay, it hits this height of 0. But when we ask for the zeros, we don't need them written as ordered pairs. If we ever ask for intercepts, they're written as ordered pairs. If we ever ask for zeros, we don't write them as ordered pairs. We just write the values where it crosses. So -2 and -6. Okay? And our y-intercepts, in this case, would be right here. That's an ugly point because it doesn't look like it's a whole number, but maybe if we knew what that value was, this would be easier. Maybe we could say this was a height of, I don't know, -1/3. We don't know exactly, I'm just creating a guess. Here's -1. Clearly it's not down to -1 yet, it's a fraction of the way there. I'm just showing you how you would write a y-intercept. The x is now 0, and then you would write the height right there. And this would be if we were writing a y-intercept. Because again, intercepts are always written as ordered pair coordinates. Okay, so this is really essential that you guys are able to follow along with this all. The next really important skill today is our positive and negative domains. So just like we looked at increasing and decreasing domains, now we're going to look at positive, negative domains. So let me look at almost that same problem. I don't know if I can draw it again. So I think it started down there. Basically it went up, it went down, it came back. Ooh, you know what? I think I might have missed a intercept. Oh no, and I can't erase it. I think there was another intercept on this right-hand side that I missed. So if you go back in the video and rewatch it, there should have been another one right there. So we'll just say that that occurs right here at x equals 1. So in the last problem, 1, 0 would have also been an x-intercept, and 1 would have also been a 0. Again, I don't remember exactly where it crossed, but I'm just assuming that's where it was right now. Okay? My apologies on that YouTube video, but I just wanted to make that correction now that I remembered it. Okay, so let's say that this is our problem. Okay? Positive and negative domains. Okay? We are once again just looking at domains, left-right regions. So we're looking at left and right zones where we have positive heights or negative heights. That's kind of how you can view this. Okay, so in fact, maybe I will even color coordinate this a little bit. Negative heights. And maybe I should get rid of some of these other colors. Hold on. Sorry guys, stay with me. You'll see in a second what I want. Done. Okay, boom. Okay, our positive heights are going to be blue. Notice these are positive heights. They're all above the x-axis. If this is the x-axis, all of these values are clearly above it. Okay? Here are more values that are clearly above the x-axis. Here would be red values below it, below the axis. Those would be negative heights. These are also negative heights. Okay? Why did I make these purple? We just identified those are called zeros, right? -6 and -2 and 1. Our zeros mean they have zero height, a height of 0. They're not positive, they're not negative, they're right there on the axis. Here are our positives, here are our negatives, okay? And we want to identify these domains. So our zeros right here, our zeros separate our domains. So 1, -2, and -6. Our zeros separate our domains. Okay? And obviously negative infinity and infinity on the right. Okay? So that kind of gives us, hey, we have a negative region right here. We also have another negative region right there. Okay, so our negative domain, so I'll write that on over here. And again, I'm going quickly because you have the luxury of rewatching this, pressing pause, slowing it down, whatever, okay? Or pausing it. Negative domain, there's two of them. There's this domain, which starts down here to the left at negative infinity, where it actually is negative there. Like, oh, sorry, we never reach negative infinity. So infinities are always parentheses, okay? And it goes to -6, which we also make parentheses because that's not a height of negative value, that's a height of 0. So this does not get included as a negative domain because we already said -6 was a 0. Unioned with our next aspect of our negative domain, -2 to 1. Because -2 is this 0, 1 is this 0. So we go from this 0 to this 0. Anything between those zeros is a negative value. Those zeros are not negative, so we don't include them. Okay? So that would be our negative domain. Okay? Our positive domain, I'm going to use blue now, positive domain, okay, goes from -6 to -2, right? That's this 0 to this 0. Basically anything between these two zeros is positive, unioned with anything between this 0 and for the rest of time is also positive. Okay? Let me show you that one now. So I'll break this concept down again, just in case you needed to see that, so you can press pause. I'll break this concept down again. Very simple problem. We'll use a line. Okay? And let me make sure that I set this exactly where I want it to be. 1, 2, 3. Have to know the 0. You have to know what the 0 is. Once you know what the 0 is, we can separate the two regions as saying this one's a negative region, this one is a positive region. Okay? And obviously here's negative infinity, here's infinity. So it is positive from -3 to infinity, and it's negative from negative infinity to -3. Again, we're just looking at x domains. Boom. From that domain to there, and then from there to there. Okay? Where -3 happens to be a very important concept. Okay? I actually like this problem also if we're looking at identifying increasing and decreasing regions. Okay? And in fact, this problem is always increasing. Even though it has negative values, it's always increasing. So our increasing domain, so I'm going back to a previous concept, all real numbers, and our decreasing domain would be never. It never is decreasing, or there is none. Okay? There is no domain for where it's decreasing. I hope this video helped.
Oh, there we